In previous lecture, we were know about the Dalton's atomic model and their concepts, as well as present position of Dalton's atomic theory and model. Now here we are going to know about the model concept of atomic model, or you can say that model structure of atomic model. Model theory of atomic model. Students, with the discovery of fundamental particles, isotopes, isobars, and the combination of two or more atoms in simple or simple fractional ratio, the concept of the Dalton's atomic theory was discarded, and here the concept of model atomic theory come in tradition. Let us know about this theory. According to this theory, an atom is the smallest particle of any substance that take part in chemical reaction, that takes part in chemical reaction. Next, an atom consists of three fundamental particles. Fundamental or principal, you can use both of the terms. Particles, electron, proton, and neutron. Next, two or more atoms, combine to form molecules, not compound atoms, as Dalton was reported in his theory. Two or more atoms combine to form molecules. Next, all atoms of a definite element or definite elements, all atoms of definite elements may not align in all respect. It means the atoms of any of the elements. It is not necessary to all the atoms are similar in all kinds of nature and behavior. Take an example, as I was also mentioned in the present position of Dalton's atomic theory, isotopes of hydrogen. It means with the discovery of isotopes, the concept of Dalton's was failed because the atoms of this element hydrogen, one H1 protein containing one electron, one proton and zero electron. Protein. Yes, students. This is very competitive question. Name the elements which contain no neutrons. Then your answer will be hydrogen in simple way. If the options are given as protium, deuterium, tritium, none of these, then you choose first protium, because in protium there is only one electron and one proton is present. Protium does not contain any neutron in its nucleus. That is exception. Deuterium 1s2, and tritium 1s3. Thus, students, this is a particular or specific type of element, hydrogen, but here there are isotopes containing different number of electron, proton and neutron. Thus, the structure of their atoms are different. So, the modern concept is that all atoms of different elements may not alike in all respects. Likewise, the atoms of different elements may be alike. What is the meaning of this concept? It means the shape of atom, or you can say that nature and behavior of atom may be alike. Either they belong to the different elements. Yes, with the discovery of isobars. As I was take the example of argon, 1840, mass number is 40 and atomic number is 18. And calcium, the atomic number is 20 and mass number is 40. Here, students, the number of proton and you can say that neutron may be similar and their mass number is equal, so that their atoms may be perform the similar characteristics. Now, students, Dalton stated that atom cannot be created and cannot be destroyed, but you know about the nuclear reactions, and in nuclear reaction how the new atom are created and destroyed. You very well know that from the previous lecture. Atoms can be created and can be destroyed by nuclear reactions. Is that clear? Yes. Next, the model concept state that atoms of different elements may combine in simple or fractional ratios. Yes, students, with the help of law of chemical combination, you would know about how the simple and fractional, how the compounds are combined in simple and fractional ratios. Now we are going to know when, how, and from, by whom the discovery of fundamental particles was carried. Today I gave you short script, and in next video lecture we explain how in laboratory these chemists discover the fundamental particles and what kind of operators they use to dispose these three fundamental particles. Now here today I gave a short description of the discovery of fundamental particles. As you all of you very well know that there are three fundamental particles present in an atom. First, here I take the serial number. Now here name of fundamental particle. Symbol through which it can be represented. Name of discoverer, or you can write a discoverer name. Discoverer name, and with you can write here discoverer name with year of discovery. Charge, what kind of charges found on them, and at last mass, what is the mass of each fundamental particles. Okay students, first I take electron, the fundamental particle. Electron, it is simply represented by the small letter E. J.J. Thomson discovered it first in 1897. He discovered it, the electron, in 1897. Electron has a negative charge, The charges are, the unit of charges is coulomb. It has minus 1.6 into 10 to power minus 19 coulomb of charge. That can be, the coulomb can be easily represented by the capital C, but here I write the full word coulomb. 1 - 1.6 into 10 to power minus 19 coulomb charge of negative charge is found at 1 electron. What is the mass of 1 electron? That is 9.108 into 10 to power minus 31 kg. Somewhere it is also writing grams, then you have to just multiply 10 to power 3 to obtain 10 to power minus 28 gram. Okay students, second fundamental particles I take here, that is proton. There is a dispute between this fundamental particle because it was firstly discovered by Goldstein in 1880, but cannot explain the characteristics of this kind of particles. He just take a view that if any negatively charged particles is present in an atom, then there is also a positive charge, so that each and every atoms are staying neutral state. That was just a concept through which the Goldstein first tell to understand there is positive particles just like to the negative particles, means electron found in atom. But Rutherford, with the help of his alpha scattering experiment, proved and also explained the characteristics of protons, so that the credit goes to Rutherford for the discovery of proton. Then I here write the discoverer name as Rutherford, and proton can be easily represented by the small letter p. It has a single positive charge of the same unit, but here minus 1.6 into 10 to power minus 19 coulomb charge is found on electron, but here only 1.6 into 10 to power minus 19 coulomb charge is found on a proton. Thus, both of the particles are antagonistic to each other. That's why any of the object in our surrounding stay in neutral state. Otherwise, each and every object has charge, so that they can easily flow the electrons, and we can witness by the shock. The mass of the proton is 1.67 into 10 to power minus 27 kg, and you can also write it minus 24 gram. And the last one is, students, that is neutron. It is represented by small m. Chadwick was the discoverer. Here I mention when and how did Rutherford discovered it in 1911. Chadwick was the discoverer of neutron. He discovered it in 1932. It is neutral particle, has no charge. Neutron has no charge over it. So this is neutral charge particles, but it has mass equivalent to proton particles, 1.67 2 into 10 to power minus 27 kg. Thus, students, one thing more interesting to remind that the discoverer of electron, proton and neutron by a sequence eta per Nachet eta पर nature. How? E means electron, enter means Thomson. P represents to proton and R represents to Rutherford. N represents to neutron and Ch represents to Chadwick. I hope students today's lecture being more interesting. Thanks students for joining today's lecture.